stop. Don't drink that juice. It's not any good for you, especially if you're diabetic. Yeah, it's not just the sugar that's in it. It's the lack of the fiber, and it's what your liver does in order to slow it down. So what I've done is I've put this video together to really show you the difference.
The standard answer is that juicing removes fiber, so sugar hits the bloodstream faster. That's true, and it's part of the story, but it undersells what's actually happening, because it makes this sound like a glycemic index problem alone. The deeper issue is about a specific sugar, fructose, and how quickly it arrives at the liver, which is the only organ that can process it in meaningful quantities.
Whole fruit delivers its natural fructose slowly. Chewing, the fiber matrix, and the time it takes to digest a piece of fruit all spread that fructose load out over an extended window, a trickle, not a flood. A glass of juice delivers the fructose from multiple pieces of fruit in one concentrated dose, absorbed quickly, with none of the mechanical slowing that whole fruit provides.
A 2009 study published in the Journal of Clinical Investigation, led by Kimber Stanhope, had participants drink beverages sweetened with fructose or glucose for several weeks. The fructose group showed increased production of new fat inside the liver, a process called de novo lipogenesis, along with increases in visceral fat and reductions in insulin sensitivity. That's the mechanism a fast fructose bolus sets off. The liver, faced with more fructose than it can immediately use for energy, converts a share of it into fat. The slower the delivery, the less of this conversion happens at any one time.
There's also a second consequence of a fast fructose bolus that doesn't get much attention: uric acid production. Fructose is metabolized differently than glucose. An enzyme called fructokinase processes it so quickly that it temporarily depletes the liver cell's available energy currency, ATP. As that energy currency gets rebuilt, one of the byproducts of the process is uric acid. Research associated with this pathway, including work by Richard Johnson and colleagues, has linked elevated uric acid production from fructose metabolism to impaired insulin signaling, independent of the fat storage route described a moment ago. In other words, a fast fructose bolus isn't only building fat in the liver, it's also generating a separate byproduct that appears to interfere with insulin sensitivity on its own. This pathway also helps explain why the effects of concentrated fructose intake in research often extend beyond simple calorie counting. The biochemical route itself, not just the number of calories consumed, appears to matter. And it's the same fructokinase pathway regardless of whether the fructose came from juice, soda, or any other source, which is part of why concentrated fructose sources in general, not just juice specifically, get flagged on this channel.
This isn't just a lab finding. A large analysis published in the BMJ in 2013, led by Isao Muraki, pooled data from over 180,000 people tracked for years. Whole fruit consumption, particularly blueberries, grapes, and apples, was associated with a lower risk of developing type 2 diabetes. Fruit juice consumption showed the opposite association. Higher intake was linked to increased risk. Same underlying fruit, opposite direction at a population scale. A common follow-up question: what about smoothies? They keep the fiber, so are they the same as whole fruit? Not quite, though they're a meaningful step up from juice. Blending breaks down the fruit's fiber matrix mechanically. The fiber is still present in the cup, but it's been physically disrupted in a way that whole chewing and digestion inside an intact piece of fruit doesn't replicate. That partial disruption speeds absorption somewhat compared to eating the fruit whole, even though the fructose isn't stripped out entirely the way it is in juice. So smoothies sit in between.
better than juice because the fiber and its slowing effect haven't been discarded, but not identical to whole fruit because blending has already done part of the mechanical work your teeth and gut would otherwise do more gradually. Store-bought smoothies often add further concentrated sugar or juice as a base, which erases even that partial benefit. So a smoothie made from whole fruit and water or plant milk is a very different product than one bought pre-made with juice concentrate mixed in. Portion and pairing still matter more with a smoothie than with a single piece of fruit eaten whole.
None of this means fruit itself is a problem. The population data points the other way for whole fruit. It means the liquid version isn't a shortcut to the same benefit, because removing the fiber doesn't just speed up digestion, it changes how much of that sugar gets converted into stored fat and uric acid before your body ever gets a say in it. If juice is part of your routine, the practical fix is the same principle from earlier scripts on this channel. Slow it down, don't isolate it, and don't treat it as a stand-in for the whole food. This matters practically because someone eliminating juice but still drinking large amounts of soda or other fructose-sweetened beverages hasn't necessarily removed this exposure. The pathway responds to the concentrated fructose dose, not the specific product it arrived in.
So next time somebody tells you juice and fruit are basically the same, you'll know the real answer. It's not the fiber alone. It's the speed your liver has to deal with. On my plate, it's whole fruit. Skin on when it makes sense. Never juiced. That kind of detail is part of what took my own insulin usage from 83 units a day down to 35 a day. Slow and whole beats fast and stripped down. Every time. If you're interested in learning more about diabetes, click the link below. That's not managing it, that's dominating it.